Alright guys, so here we're just doing a little recap on some things. So last week we talked about electromagnets, or you saw that in your reading guide. And so an electromagnet has a coil of wire, and when you run current, or you have a flow of electrons through it, it creates a magnetic field. And so it's pretty cool that compasses deal with that. So let's try to show you essentially what a compass does first. So what a compass does is it follows, it's just a magnet. So see how the north end is red? So then this is a north end. So if I try to bring this around, you'll notice those north ends stay away from each other. Where if I brought this, no matter what happens, that north end doesn't want to be near each other. So just like with protons, neutrons, and electrons, like things repel and opposites attract. So here, the magnets are all in one direction, so that's the magnetic field. Okay? And also a compass will follow this field. Okay? So it's going to go along this as it goes, kind of goes out of the north and into the south is what happens. So that's what when you use a compass, you kind of follow along these lines and it takes you where you need to go. Some other cool things with a compass. Right. So if you look here, right, as you set a compass down, you're going to see these field lines end up in here. And so these are just little pieces of metal filings, but they're going to line up because there's a magnetic field, so they'll start to line up along the lines. So that you can see this person doing here showing you those well, they're there, but you just can't see them, those invisible field lines. And also, I think this is a great one. These compasses show you that that's the line that you would walk. So a compass is also just a magnet as well. The north side of a compass is attracted to the south, and so on. So you can see those. So again, back to our electromagnet. So as you get a electric current going through, remember that coil of wire and electric current creates a magnetic field. So here you have your magnetic field going in this direction, right? And so that's where the compass will do things. As you can see, if you switch the direction of the current, it changes the direction of the magnetic field. So the magnetic field is pointing to the right. If I switch the current, then the magnetic field is pointing to the left. So we can have those different things that we have there. So our electromagnet coil of wire, you have a current, creates a magnetic field. The generator, you change that magnetic field, right, as I'm spinning this magnet, and that creates a electric current. Okay? No changing in the magnetic field. For a generator, then you do not get any electric current. But if I'm changing that, then I have this issue. So those are our big things that we needed to see in those differences between those two things. One last piece I wanted to show you. So here, you can't really tell yet, but they're going to turn this on, and then you'll start to see that these things will change. Okay? So let's watch this. Oops, I watched at the end. So it's kind of cool. There's this thing called the right-hand rule, and it tells you where the magnetic field goes. So you put your thumb where the current is going, and then curl your hand around, and that's where the magnetic field's going. So what's happening is this current is going up this red wire. So as you curl your hands around, that's how you're going to see these compasses line up, because they're creating a magnetic field around there. So let's watch. Once we see them turn the switch, here it looks like they're all going in this direction, but once they turn it on, you'll see that loop, that they're showing you there. and flip. And now you can see all of the compasses are following this direction. Right? Then it's pretty cool. They're able to adjust the current and make it go the opposite way. So then your hand would be going down, and as you curl your hands, and I think she'll show it here, that they'll go the opposite direction. And so that's kind of what you can see, the differences that we have there.